Alrighty, you have made it to the final topic. Topic 7, which is dividing polynomials. You may be thinking, well, what have we been doing this whole time? So again, factoring and dividing are two different things. And I'm just going to real briefly, even on this title slide, talk about that. There's nothing in your notes here. If we were to factor the number 48, for example, we would break it apart, possibly into like 24 and 2. Okay? That's turning it into its factors. Dividing it would be like, well, what is 48 divided by 4? Well, I do long division and I figure it out, right? Oops, 0. 12. You could also consider thinking about a prime number, right? Well, 7. 7's prime. It can only be broken down into 1 and 7. But does that mean that you can't divide it? Well, no. For example, 7 divided by 2. 2 goes into 7 3 times. I subtract, I add my decimal point, 2 goes into 10 5 times, and we get 2.5, or 3.5, sorry. So dividing and factoring are two different things, but they're very similar because it is breaking it down into two multiplicative things that will multiply together to give you that product. So it says, consider the problems below. Christina has a garden with an area of 3x squared plus 7x minus 6 square feet. Write that in here. She knows the length is 3x minus 2. What is the width? Well, again, we would solve this with factoring. I would do my x factor. The top I'd have negative 18. The bottom I'd have 7. What times what gives me negative 18? Adds to 7. Thinking 9 and 2. Subtraction sign would be on the 2, or the negative sign. I can't use that special trick I taught you in topic 4. I have to just break apart my middle term. So I've got 3x squared plus 9x minus 2x minus 6. So then I'm going to group, oops, x plus 3, take out a negative 2, be x plus 3 as well. So I'm left with x plus 3 times 3x minus 2. Well, again, looking at this rectangle, I already knew the 3x minus 2 part. I already had this. So the width that they were looking for is x plus 3. Okay? That's what you've been working on throughout this whole unit. So now look at this side. This is Christina's garden. She has a garden with an area of 266 feet, and they say that the length of her garden is 14. What is the width? Well, am I going to sit here and factor this, or would I do something else? Most likely, we would divide, right? We would take 266, divide it by 14. Well, 26 goes into 14 goes into 26 one time. I subtract. Bring down my 6. 14 goes into 126, I believe, 9 times. 3, yep. So now I know that her width is 19, which is probably actually her length, but that's okay. So down here, it says, as mentioned previously, factoring is one way to undo multiplication. Well, what have we done in the past to undo multiplication? We have simply used division. And that's what we're going to do today, is just divide, okay? Like we did with the problem on the right, rather than trying to factor. So we're going to start actually with a old school division problem. 2,675 divided by 25. Now, you may have learned all kinds of different methods to divide, but we're going to focus on just old school long division algorithm, okay? So what you've learned in the past, I'm going to actually walk through very slowly because it applies to what we're about to do with polynomials. So it says 25 into 2,675. Well, can 25 as a whole go into 2? Well, the answer is no, so I'm going to skip that, right? But it can go into 26 one time. Well, where do I put the 1? I put it over the 6, okay? So then I multiply 1 times 25. I multiply those together, and I get 25. Okay, then what do? I subtract all of 25 from 26. I'm left with 1. Okay, well then I bring down the next number, which is a 7. Okay, well how many times does 25 go into 17? Well, it doesn't, right? But I have to still put something up here. So it goes in 0 times. Now I multiply. 0 times 25 is 0. I'm going to subtract all of 0 from 17, which is still just 17. Now, I bring down the next number, which is a 5. And I think, okay, how many times is 25 going to 175? Well, it goes in 7 times. Then I multiply 7 times 25. I get 175. I subtract all of 175. I'm left with 0. So I now know that 2,675 divided by 25 is 107. Okay? We're going to use that exact same process to divide polynomials. Okay? So this time we're going to do 27x cubed plus 9x squared minus 3x minus 10 divided by 3x minus 2. So we're going to set it up exactly the same. Draw my little division house, which is going to be kind of big. 27x cubed plus 9x squared minus 3x minus 10. I'm dividing it by 3x minus 2. Okay, so similar language here. What's a little bit different is that you're only going to look at the first piece of what your divisor is. So 3x, right? How many times does 3x just go into 27x cubed? In other words, 3x times what would give me 27x cubed? Well, I would need to have a 9, right? 3 times 9 gives me 27. Then x times what gives me x to the third? Well, x squared. Well, if that's the number I want to use, I need to put this above the correct part of my problem, okay? And you might think, oh yeah, so she's going to put it above the 27x cubed. Unfortunately, I'm not. I'm actually going to put it above the x squared because this has an x squared, okay? Now, it's total coincidence that they both say 9. So 9x squared. Now, the next part was to multiply that top number by our divisor. So 9x squared times this. I'm actually going to multiply the whole thing now. Even though I just divided by the 3x to begin with, I'm going to multiply the whole thing. So 9x squared times 3x is 27x cubed. 9x squared times negative 2 is negative 18x squared. Okay, well now I'm ready to subtract, but I'm going to subtract this whole thing, okay, which is actually pretty important. So 27x cubed minus 27x cubed. Well, that's 0, nothing, that's good. But now 9x squared minus a negative 18x squared. Well, that actually is a positive, right? This negative and this negative actually make a plus. So what is 9x squared plus 18x squared? 27x squared. Okay? I'm then going to bring down the next term, minus 3x. So now the process starts over. Okay? Again, I'm going to look at just 3x right now and see how many times it goes into 27x squared. This right here. Well, 3x times what equals 27x squared? Well, again, I need the 9, and I just need 1x, because x times x is x squared. Because this place value is just 1x, I'm going to put it above the 1x portion. So plus 9x. And now I'm going to multiply, again, by this whole thing. So what is 9x times 3x? 27x squared. What is 9x times negative 2? Negative 18x. Okay, and I'm going to subtract this whole thing to see what's left over. 27x squared minus 27x squared is 0. Negative 3x minus a negative 18x. Well, again, that creates a positive here. Okay, so negative 3x plus 18x is actually 15x. Then I'm going to bring down my last piece, minus 10. Okay, start over again. So now, again, 3x, how many times does it go into just 15x? Well, just 5 times, plus 5. So then I multiply. 5 times 3x is 15x. 5 times negative 2 is negative 10. I'm going to subtract this whole thing. Well, what is 15x minus 15x? Nothing. What is negative 10 minus a negative 10? Well, that's actually plus 10. So again, 0. We have nothing left over. So my official answer is now this guy. Okay? Now, you may be thinking, good gracious, why would we ever want to do this? Well, look back at your original quotient they gave you. 27x cubed, 9x squared, blah, blah, blah. There's no greatest common factor. We could try to group it, but if you do, you'll actually find that it doesn't work. You can't do the x factor because there's 4 pieces. Basically, you can't solve it by any of the means that we've taught you. So this is really the only one that will work, okay, until you learn how to factor bigger terms. So the rest of this video is just trying this again and again. I promise it gets easier the more you do it, so hang in there. All right. Big old division bar. X cubed plus 7x squared minus 6x minus 72 divided by x plus 6. Okay, so again, I'm just going to look at the first piece here. How many times does x go into x cubed? Well, x times x squared is what would give me x cubed. So now I multiply x squared times this, the whole thing. So I get x cubed plus 6x squared. I'm going to subtract that whole thing. X squared minus x squared is nothing. Now I'm going to do 7x squared minus the 6x squared. Gives me just 1 left over. Okay, so now I bring down my next piece, which is minus 6x. And again, I'm just going to look at the x for now. How many times does x go into x squared? Well, just 1x time. Multiply. X times x is x squared. X times 6 is positive 6x. So I subtract this whole thing. X squared minus x squared, that's nothing. Negative 6x minus 6x over here, that's actually negative 12x. Okay? Think about this negative as like being distributed here. You're subtracting 6x from 6x. That's negative 12x. Okay, then I bring down my next term, my last term, negative 72. And again, just looking at the first piece, x. How many times does x go into negative 12x? Well, it goes in negative 12 times. And I multiply, so we've got negative 12x minus 72. I'm going to subtract all of that. And you'll notice, again, if you kind of picture this being distributed, negative 12x minus a negative 12x, that's nothing. Negative 72 minus a negative 72, that's nothing. So my final answer is x squared plus x minus 12. Okay, you can always test this also. If you are completely clueless and you have no idea if you did it right, you can always multiply it back together just by doing the double distribution to see if you get the same polynomial as you had when you started. That's another way to check. All right, just going to keep on going here. It says find the width of the rectangle below by factoring, and then over there it says find the width of the rectangle below by using long division. So we're going to do it both ways. Factoring, this one does not have a greatest common factor, and it cannot be grouped. So I'm going to do the x factor. Let's see. This will be 6 and 1. 6 has to be negative. Can't use my little shortcut here, so I have to go the long way. And group. Take out a negative 1. Oh, no. What did I do wrong? Oh, just take out a positive 1. So I'm left with, oops, 2. X minus 2 and 3x plus 1. They already gave us the x minus 2 in the actual problem here. So my answer would be 3x plus 1. Now you'll notice these two problems on the left and right hand side, they're literally the exact same. So I should still get 3x plus 1 when I do this by long division. Okay, so I'm going to set up my problem first. And then I'm going to use the steps that I've been talking about. So I look to see how many times can just this x go into 3x squared. Well, it goes in 3x times. So I'm going to put it on top of this 5x. So then I multiply 3x times x minus 2, and I get 3x squared minus 6x. I'm going to subtract all of this. Okay, again, this negative and this negative actually make it a plus 6x. So negative 5 plus 6 would be just x. Bring down minus 2. Again, I look to see how much does this x go into this x, and let's say just 1 time. I multiply, subtract all of that, and I get 0. What do you know? I again got 3x plus 1. Okay, So long division and factoring both accomplish the goal of undoing division. It's just a matter of sometimes factoring won't work, okay? So whenever you're looking at that flow chart that we've been using, if you get all the way down to the x factor and it won't work, technically, it's not prime because it can possibly be divided by something. But just like the number 7 is prime, 7 can still be divided by all kinds of stuff, right? 7 can be divided by 2 and we get 3.5. 7 can be divided by 4 and we get something else, 1.75, etc. But it's still a prime number, okay? So you'll get into that more in Algebra 2. I don't want to spoil the surprise or make your brain explode. So don't stress over it too much, but just know if you're asked to use long division, this is the process I'm talking about. Continuing on. I think we should have 4 more examples. This might be the longest video yet. If you feel like you've got it, again, at any point, feel free to pause, and I will keep talking. So you can always just fast forward past me and check. But I'm going to keep explaining for anybody that still feels a little bit unsure. So here's my setup. I'm going to just look at 4x and see how many times that goes into 12x cubed. It goes in 3x squared times. So now I multiply. Oops, it should be 3. Now I subtract all of this. Remember, this negative kind of goes across to this 9. So it's negative 11x squared minus 9x squared. So it's negative 20x squared. Okay. Then I look to see, okay, how many times does this 4x go into negative 20x squared? Here's something a little tricky. It actually goes in negative 5x times to create that negative. I'm going to subtract all of this. So I've got 0 over there, but then this is 9 plus 15x. So that is 24x. Bring down my 18. Then again, how many times does just the 4 go into 24? Goes in 6 times. Multiply. This looks promising. I subtract all this and I get 0. So my answer is 3x squared minus 5x plus 6. Okay? I'm going to have to erase this to work out number 2. So pause if you haven't finished writing it down. So now, same thing again. R cubed minus 12r squared. This is a long one. Plus 32r minus 15. I guess it's just the same as the other one. R minus 3. So again, look at your first term. R goes into r cubed. Really just r squared times. R cubed minus 3r squared. Subtract all of that. So we've got negative 9r squared. 32. Then again, just look at the first one. R goes into negative 9r squared, negative 9r times. You have to include that negative. Okay, let's subtract all of this. So again, that negative kind of gets distributed here. So 32 minus 27 is 5r. Bring down negative 15. R goes into 5r. Just 5 times. Subtract all of that, and we'll put 0. So my final answer is r squared minus 9r plus 5. Alrighty. All right, there's really only 2 more. I'm going to go ahead and pause and work these out. You'll notice number 4 is super long. So I will, again, I'll show all my steps so that you can see how I did it. But it's the exact same process, even though it's a polynomial with 5 terms divided by a trinomial. And so far, we've just been doing binomials, but it's the exact same process. So I'm going to go ahead and pause the video and work mine out. Y'all pause and do the same. Okay, so let me scroll back up. There are my 2 problems. Answers and worked out with the work shown. Again, hopefully that second problem didn't trip you up too much. You'll notice that I skipped 2 places here. I skipped this. I'm not going going to do next. That would be confusing. I skipped this little area and this little area because x squared only went into x to the fourth an x squared number of times. I had to write the x squared on top of the x squared in my dividend. Okay? But again, the answer is x squared minus x plus 1. So we scroll down so you can kind of see the work for the bottom one as well. If you need any more help with this, again, make sure you ask your teacher. There are tons of videos online that go over this as well. And I think an optional video has been placed in the School Do folder that you can look at if you want to hear just a different voice explain it, maybe a slightly different way. But the best thing you can do is really just practice it. It gets way easier, I promise. It's kind of like the first time you learned to multiply two-digit numbers. 22 times 14. That was mind-blowing once upon a time, right? The fact that you had to remember to put this 0 here, it just felt like you were never going to get it. And then you had to add. It was just insane. So keep in mind, this will get easier the more you do it. So do the practice that comes next, and then hopefully you will ace the quiz that comes a little bit later.